In this video, I'm going to do the try these problems from lesson 4, logarithmic equations. And we're going to learn, why do we even learn about logs? For example, if I gave you 3 to the x equals 9, we wouldn't have to use logs. We know 3 squared is 9. But we don't know the exact answer. What do I raise 4 to? Now, in the past, sometimes people would say 5. 4 times 5 is 20. This is not multiply by. This says, how many groups of 4 do I take times itself in order to end up with 20? The reason we learn about logs is so that we can solve equations that have variables in the exponent position. So what we do is, remember, just like we've done in the past, I'm going to give you an example. If I give you something like this, and I say solve, you all know at this point we simply subtract 2. But we are taught whatever we do to the left, we do to the right to keep it equal, and we end up with an answer of 3. Whatever you do to the left, you do to the right. We're going to apply that same theory in order to keep this equation balanced. So I'm going to write log base 4 on the left and log base 4 on the right. And now I'm going to bring down exactly what I had. Let me see if I can take a different color so it stands out for you. 4 to the x and 20. Okay. Log base 4 of 4. So what we do is we take this exponent position, if we're talking mathematically, and we throw it in front. So it's x times log base 4 of 4 equals log base 4 of 20. Log base 4 of 4 means this. It means 4 raised to, now I'm a visual learner, 4 raised to what exponent equals 4? And we know the answer is simply 1. So this entire thing is not just going to disappear, it's going to simplify into 1. And I know 1 times x is just x. In the future, when you see the log having the same base as the number behind it, that group will simplify to 1 every time. So it could be like log base 9 of 9, it's equivalent to 1. Log base 10 of 10, it's equivalent to 1. Log base e of e, it's equivalent to 1. So this is equivalent to 1. I bring down the x. And now this goes back to, this is the reason why we have to use a calculator in order to evaluate this. To get to this piece, you're going to hit the math button and you're going to hit the arrow up 3 times on the newer calculators until we're able to change the base. I'm pressing enter. My base is 4 and the value behind it is 20. And let's go ahead here and let's round to the nearest hundredth. So x is approximately 2.16. X is approximately 2.16. Let's take a look at number 2. So I'm going to flip this over to the side here so we can see it. Remember, E is Euler's number. It's simply a number that's often seen in real mathematics. So I'm going to add 5 to the opposite side. Whatever I do to the left, I must do to the right. I'm going to divide by 2. Whatever I do to the left, I must also do to the right. And this is the reason we have logs. The reason we learn logs is that when we can't do basic math in our head in order to find this exact value, we need to use a log. If this again was 3 raised to the x equals 9, we know the answer is 2. That's not the case. So how do I solve for x? Whatever this value is, we're going to take the log of that number. So whatever I do to the left, I must do to the right. So log base e and log base e. And now I write down everything that was previously there. There was a 6 there, and there was an e to the x. If we go back to the last problem, I shared with you that when the base of the log is the same as the number behind it, it simply turns into a 1 and the x comes down in front. So I have 1x equals log base e 6. In the videos you watched with Mr. McFarland, we learned that another way to express log base e is there's a shortcut key, and it's called the natural log. So log base e can also be written as ln. These will produce the exact same answers, and I'm going to demonstrate that right now. So I'm going to first do the first one. I'm going to do math. I'm going to go up 3 keys. And now how do I get the e? It's on the left-hand side. So there's e, and e the first, and then I'm going to raise it here to the 6. So this is the answer if I plug it in as is. And now when I use ln and I do ln of 6, we get the exact same answer. So approximately 1.79. Most students, when they see log base e, are going to simply use the shortcut key, which is the ln. But you can also recognize that we could use log base e. Let's look right now at number 3. I first want to isolate the 10, so I'm going to add 4 to both sides. Okay, now what is the variable, what is the exponent on the 10 on the right-hand side? Anybody? What is right here that I don't see? There's a number. A 1. When the bases are exactly the same and they're separated by an equal sign, so there's no additional. I want to show you what I do not want to see. I do not want to see something like this. So there can't be any additional adding or subtracting or multiplying in front. When the bases are exactly the same, we're able to cancel out the bases, and now we get to just simply solve this equation. So I'm going to subtract 3 to the other side, and I get x equals -2. X equals -2. And we could demonstrate how that does work. We could demonstrate how that works. I come up here, I have 10 raised to the -2 plus 3. I bring it back down, I subtract 4, and I better get an answer of 6, and I do. I'm able to achieve 6. This is the correct answer for number 3. We're going to do the same concept for number 4. I want to isolate the 2. So we're doing PEMDAS backwards. First we're adding, subtracting, then multiplying, dividing, and then we'll take care of the exponent. So first, remove adding or subtracting from the side that has the variable in the exponent position. 2 raised to the 3x minus 1 equals 8. Okay, now I want to rewrite this just like I was able to do number 3. If I come back here, notice how I got to this position. I need the bases to be exactly the same. So I need to be creative here. What's another way that I could rewrite 8? I need the same value of 8, but I want to have a 2 as the base. So what I'm asking you is, can I raise 2 to some specific power and end up with 8? 2 to the third. So let's write this as 2 to the third. Now we have the exact same bases. We're able to cancel out the bases, and I bring down the exponents. 3x minus 1 equals 3. I'm going to add 1 to the opposite side. 3x equals 4. And once we divide by 3, we end up with an answer of 4/3. We could always go back and make sure we did it correctly. I'm going to grab the calculator, come back to this original, and I do 5 plus 2 raised to, now I'm using a fraction, so I'm going to use parentheses here, and I have 3 times the quantity 4/3, subtract 1. This answer should equal 13. If it does, then I chose the correct answer. Okay, let's do number 5. So I'm going to teach you right now, which just sounds really silly, but I'm going to teach you a disco move. Do you guys know this disco move here? Do you guys know this simple disco move? Yes? Kiddos over there, do you know this one? Yes, yes, yes. Yes, okay. So I'm going to stop this for 1 second, and I'm going to come up and just show you this. If I showed you this, okay? If I showed you this, this is how the disco move works, okay? Your base is what number in this problem? What is the number? I see a 5 and a 25. Which number is considered the base of that problem? It's a number that's down below. It's the 5 in this case. So take your right finger right now and point it towards your left hip. Right now, everybody do this. Point it towards your left hip, not your left shoulder. That's your base. Does everybody see how it's pointing down? Okay, now I'm going to put on some disco music soon for you, Abby, make you start dancing. I know you like to dance. Now I want you to go across and point to the opposite ceiling, the opposite way. Okay, that's where you're going to grab the exponent, and then come back to your heart, and it tells you. So with that understanding, if you're just here in class, we practiced a few problems using some kinesthetic moves of disco move, and we're going to rewrite this. So I start with the base. My base in this problem is 2. I go to the opposite side. So if you're doing this disco move, you point your finger to the opposite corner and you point. It raises up to the 5th power, and it comes back, and this is my answer of x. So this is not 10. It's taking 2 times itself 5 times 2 times 2 times 2 times 2 times 2. Anyone? The answer is 32. The answer is 32. I'm going to try another one like that for you. Please don't blurt it out, because I can tell people at 5 in front of you have practiced this at different lengths. So go ahead for me, please. And I want you to come up with this answer in the next 30 seconds. This is just another practice problem. 3 is the base, raise it to the opposite number, comes back and equals x. 3 to the 4th is not 12. That's a misconception. 3 times 3 times 3 times 3, 4 times is an answer of 81. Let's go on right now to number 6. Let's look at number 6. Do you want me to go back over that one quick? Just a quick raise of hands. Do you want me to do that one again? No? Okay. Here we go. I'm going to rewrite ln as log base e, so there's less confusion initially. I'm going to rewrite ln as log base e. Log base e and ln are interchangeable. They're interchangeable. So when we go about solving for x, we're going to do PEMDAS backwards. So I'm going to start by adding or subtracting first. This is not in parentheses. This -2 is not connected with the x. So I'm going to add 2 to the opposite side. I'm going to divide by 3. And now whatever the base of the log is, if I take this value and I make both of these turn into exponents, so I'm going to write them a little bit smaller. I take whatever the base of the log is and I make that the base and this the exponent, and whatever you do to one side, you must do to the other side. So I've done it to both sides. What this does is it forces the e and the log base e, they simplify into 1. They simplify into 1, and I get to drop down whatever was this remainder. So the remainder behind it was x. So x equals e to the 3rd power. I'm going to grab my calculator. I'm going to take e to the 3rd, and then we are going to go ahead and simplify this as x is approximately 20.09. I'll practice another problem like number 6. Again, I'm doing PEMDAS backwards. So I first start on the side that contains the x, and I'm going to rewrite ln right now as log base e. So log base e, I've moved the 4 over. I know 29 minus 4 is 5. I'm dividing by 5. I get log base e of x equals 5. Now, in order to solve for x, I'm going to take whatever the value is. E is a number, Euler's number. I'm going to take whatever this value is, and I'm going to make it the base. So I have e's on both sides, and these other portions become the exponents. On the left-hand side, the e and the log base e are going to simplify into 1, and I bring down the x. I'm going to plug this into the calculator, and I get e to the 5th power is approximately 148.41. Another practice problem like number 6. I'm subtracting 6 to both sides. And I'm going to change the ln into a log base e. I'm going to divide by -4. I have log base e of x equals a +4. And now in order to solve for x, I'm going to take whatever this numerical value is. In this case, it's the number e. I'm going to write it on both sides. And I have log base e of x and 4. These will always simplify into 1. I bring down the x. And now I'm just going to take e to the 4th. So what is e to the 4th? E to the 4th is approximately 54 point, well, we could round that, 54.6 if we rounded it. Let's look at 7 and let's look at 8. So again, I'm going to do the exact same thing. I'm going to identify what side has the variable, and I'm going to use PEMDAS backwards. That means first I'm going to add or subtract, then multiply or divide. So let's subtract 8 from both sides. The 8's cancel out, and I bring down -2. Log base 3 of x equals -6. After that, I'm going to divide by the -2. Log base 3 of x equals 3. And by the way, we know this one. Like, we can use a calculator, and I'm going to show how it still can work, but we know this one. So think of doing the silly little disco move. You're going to take and point to your left hip right now and ask yourself, 3 raised to the 3rd power, come back to your heart, equals what? 3 to the 3rd is A little bit louder. 27. But let's pretend you didn't know that. What could we do? We take whatever the base is, I write it on both sides, and then I write these values as the exponent. This is going to reduce down to 1. I drop down the x, and I have 3 to the third if you needed to use a calculator. Otherwise, 3 times 3 times 3 we know is 27. Move my 6 to my opposite side. Negative 2 log base 10 of 8x plus 4 is equal to, when I move the 6 to the opposite side, 2 subtract 6 is negative 4. Log base 10 of 8x plus 4 is equal to 2. All right, now this comes back to what I need to do. So I need to solve for this x, which means I need to somehow eliminate log base 10. I take whatever this value is, and I make it the base on the left and the right, and I turn this into the actual exponent. Now on the left-hand side, the 10 and the log base 10 are going to simplify to 1, and I drop down whatever was behind the base, so 8x plus 4. I know 10 squared is 100, and then I can solve by subtracting 4. And if you guys take 96 divided by 8, what do we get for a value? 96 divided by 8 is what value? Is it 12? It is 12. This is like problem number 8. It is a different problem, but just additional practice. I'm going to start by doing PEMDAS backwards, so I am going to start by subtracting 7 from both sides. Negative 5 log base 3 of x plus 2 equals negative 25. And divide by negative 5. Log base 3 of x plus 2 equals positive 5. And now I want to remove the log base 3 so I can solve for the x. I take whatever this value is, and I'll just show you what I do right now. It's a little bit lazier, but I just take whatever this value is and I write it as a base. That becomes the exponent, base, and exponent. 3 and log base 3 are going to simplify to 1, and I drop down x plus 2. Now 3 to the 5th, this is not 3 times 5, it's 3 times 3 times 3 times 3. Can you please check for me? I believe that is 243, but can somebody check and confirm? Is 3 to the 5th 243? So 243, subtracting 2, x is equal to 241.